Team 20 was given a product to design by Team 19, and we believe we have exceeded the expectations given. We will be showcasing our design process and the results of our design to show how Team 20 designed the best product possible. Given the following design description, when a button is pushed, the machine will move forward until an obstacle is in its path. Team 20 designed a product that will meet these expectations.
After reviewing the design description given by Team 19, Team 20 found 3 essential questions to the build of the robot. The first being, at what rate should the robot travel? To which we received the answer of 2 inches per second. The second question was, what is an acceptable margin of error for stopping distance? To which we received an answer of plus or minus 1 inch. And the third and final question being, are there dimensional constraints placed on the robot? To which we received 16 inches by 6 inches by 4 inches tall.
Team 20 was influenced by previous designs to design a machine that goes in a straight line following user input of a button and stops 6 inches away from an obstacle. The following customer needs were: a button must start the program, the machine must move in a straight line, and it should not come within 6 inches of an obstacle. The technical need for starting the program was the time it takes for the program to start, in which the requirement is that it starts immediately as the button is pressed, and the target value is 0.1 seconds. To make the machine move in a straight line, the technical need was deviation from line on the ground, and the requirement was do not move more than 3 inches off of the line with a target value of plus or minus 1 inches. To not come in within 6 inches of an obstacle, the technical need was distance from obstacle, and the technical requirement was should stop at least 6 inches away, where the target value was 8 plus or minus 1 inch. Following the engineering specifications, this system diagram was developed in which a user input starts the program start method, which in turn the brick pie housing relates to the obstacle detection method, the battery system, and the movement method. The obstacle detection method has the output of stopping movement, while the movement method outputs forward movement.
After generating a systems diagram, we then came up with a bunch of preliminary ideas and then had to analyze a bunch of these alternatives to come up with a final design. Primarily, we started to consider whether we wanted a single versus dual motor, but dual motor won out during testing because we had a pull to whichever side the motor housing was situated on, regardless of whether it was an open or closed differential. Next, we moved on to brick pie versus Grove pie ultrasonic sensor. This is a pretty simple decision. We chose the brick pie ultrasonic sensor ultimately because it integrated with the other LEGO components far more easily. We then went on to see whether a trike versus a square wheelbase was in order, and pretty quickly we realized that the square wheelbase was going to be optimal just due to the ease of creation around the sensor mounts and everything. And finally, we considered whether we wanted a front-wheel drive versus a rear-wheel drive vehicle, and upon implementation, because it's pretty easy to switch between both of these since it only goes in a straight line, we found that front-wheel drive was definitely superior because the rear-wheel drive setup was a bit unpredictable as to where it would pull to, whether that was left or right. So that's essentially what we settled on, which leads to our final design. The final design consists of an ultrasonic sensor that's situated between the two front motors that are powering our wheels, and you can see in one of the diagrams that we have a touch sensor as the button used to start the vehicle and then promptly stop it after it detects an obstacle. As mentioned previously, it's a dual motor front wheel drive design, and now we'll go into the results to show how well we quantified and met the specifications given to us by Team 19.
After final testing had concluded, we determined that the machine stopped with 8 inches distance from the obstacle, and upon inspecting the route the robot took, it only deviated from the path by 0.75 inches after traveling over 3 feet. The following is a demonstration of the robot in action.